Ball mill principle. It works on the principle of impact and attrition. It also depends on the speed. At low speed with sliding, at high speed centrifuging, and correct speed with cascading. Work in the first the material are fed into the metal cylinder and then start the machine and adjust the speed. At medium speed cascading, the centrifugal force develops which tend the ball to move up to roof and falls. Orifice meter principle. Orifice meter is a thin plate containing a narrow and sharp aperture. When fluid is stream is allowed to pass through a narrow constriction, the velocity of fluid increases as compared to upstream. This results in the decrease in the pressure head and difference in the pressure may read by manometer. The fluid velocity at thin constriction mu naught is equal to c naught root mean 2g into delta h, where mu naught is equal to velocity of fluid at point of orifice meter, that is meter per second. So that is the difference in the head from the manometer. Mechanism used for the size reduction of the particles: attrition, impact, cutting, and compression. Attrition. Attrition arises from the particles scraping against one another or rubbing action which produces shear force that reduces the size of the particle. Okay. अनमिल पार्टिकल्स एट्रेशन के द्वारा स्मॉल पार्टिकल्स में कन्वर्ट किए जाते हैं जिसका साइज 1 to 50 माइक्रोमीटर. एग्जाम्पल ऑफ फ्लूइड एनर्जी मिल. Impact. In this method, the material is kept stationary and impact involved by hammer or bar at a high speed. That is hammer mill. Particle size 50 to 8000 micrometer. Cutting. In this method, the material cut by a sharp cutter mill. This method is used for soft and fibrous drugs. The size ranges is 100 to 80,000 micrometer. Compression. In this method, particle crushed between the roller by application of force, that is roller mill. Particle size is 50 to 10,000 micrometer. Law governing size reduction. In the reduction of particle size, various law involves Bond's law, Rettingle's law, and Kick's law. Bond's law. According to this law, the work used to reduce particle size reduction is inversely proportional to the square root of its diameter of particle produced. E by W is equal to root में 100 upon d2 minus root में 100 upon d1, where E is equal to energy required, W is equal to bond work index required, d1 is equal to diameter of sieve aperture that allow 80% of mass of the feed to pass. d2 is equal to diameter of the sieve aperture that allow the 80% of mass of ground material to pass. Rettingle's law. According to this Rettingle's law, work used for particle size reduction is directly proportional to the new surface produced. E is equal to kr 1 upon d1 minus 1 upon d2. E is equal to energy required. Kr is equal to Rettingle's constant. d1 is equal to initial size and d2 is equal to final size. Now, Kick's law. According to this law, energy needed for the reducing size of particles. E is equal to energy required. d1 is equal to diameter of initial particle size. Now, hammer mill. Principle. It works on the principle of impact. Pulverization or grinding of substance is the main mechanism. Construction. Hopper, hammer mill, roller shift, feed, receiver, screen, and product. Hammers made up of hardened or stainless steel. Impact surface is made up of haystillite and carvalloy, that is abrasive resistant material. Working. Firstly, the material is put into the hopper which is connected with the drum. The hammer is fixed to the central floor. Now start the machine and hammer will start hitting drug particles. By the impact, particle size get reduced to desired size. Impact speed rotor up to the 10,000 rpm applied. After size reduction, the powder particle is stored in the receiver through skin. Uses. It is used to grind raw materials, herbal medicine, and sugars. It is used to reduce particle size. Merits. It requires moderate energy, easy to install. Its maintenance cost is low and it is easy to manufacture. Demerit. Cannot be used for grinding hard and abrasive metal. Produce more heat. Application of size reduction to determine the particle size for production of tablets and capsules, to improve mixing of powders, to improve solubility and stability of particle during production, to optimize fluid rate, agitation, screening during production. Quality control of the raw materials useful in the production of the following like tablets, capsules, suspension, emulsion, ophthalmic preparation, ointments and etc. Now we are going to study about the official standard of powder. Indian Pharmacopoeia has prescribed a standard for powder or for pharmaceutical purposes. Accordingly, degree of coarseness or fineness is placed with the reference to the normal aperture size of sieve through which powder is able to pass. Indian Pharmacopoeia (IP) specifies 5 grades of powder. Okay, the grades of powder, that is coarse powder, moderately coarse powder, moderately fine powder, and very fine powder. That is the differences. Sieve through which all particles must pass. Nominal mesh aperture size, sieve through which 40% particle pass. Nominal mesh aperture size. Coarse powder 10 1.7 mm 44 355 micrometer. Moderately coarse powder 22 710 micrometer 60 and 250 micrometer. That is nominal mesh aperture size. Moderately fine powder 44 355 micrometer 85 and 180 micrometer. Fine powder 85 and mesh aperture size 180 micrometer. Very fine powder, that is 120 and 125 micrometer. Coarse powder, a powder which passes through a sieve with a nominal mesh aperture of 1.70 mm and not more than 40% pass through the nominal mesh aperture of 355 micrometer is called coarse powder. Now, moderately coarse powder, a powder which passes through a sieve with a nominal mesh aperture of 710 micrometer and not more than 40% pass through the 250 micrometer is called moderately coarse powder. Now, moderately fine powder, a powder which passes through a sieve with a nominal mesh aperture of 355 micrometer, not more than 180 micrometer is called moderately fine powder. Now, fine powder, a powder which passes through a sieve with a nominal mesh aperture of 180 micrometer is called fine powder. Very fine powder, a powder which passes through a sieve with a nominal mesh aperture of 125 micrometer called very fine powder. Now we will study about the cyclone separator principle. It works on the principle of the centrifugal force which is used to separate solids from the fluids. Construction. It consists of a short vertical cylinder vessel with a conical base. Tangential inlet, fluid outlet. Vortex centrifugation, cyclone cylinder, solid outlet. The upper part of vessel is fitted with the tangential inlet. The outer is arranged at the base. Working. Firstly, the suspension is introduced into the cylinder vessel through tangential inlet with the high speed air pressure. It creates a centrifugal force by high speed of air pressure. Solid particles are thrown out through the cyclone valve due to the rotatory movement which fall down on conical base and removed. A small particles expel out from the fluid outlet. Usage. It is used for the separation of suspension of solids and liquids. Merits. Involved low capital cost. Can operate at high speed. Maintenance requirements are less. Sieve shaker. It works on the principle of agitation, vibration, gyration. Construction. It consists of a machine with different sieves, numbers and sieves. Sieves with different numbers assist to separate particles of different sizes. When machine starts, it vibrates and agitation occurs which helps to separate particles of different sizes. This is the figure. Pan 40, 80, 120 and 240. Working. First layer sieves are arranged or placed one upon another on a collecting pan in such a way that sieve with a small aperture at the bottom and largest aperture is at the top. The sieves are shaken for 20 minutes. Now the powder is received from the sieves. Usage. It is used in the dosage form of tablets and capsules. Merits. It is an economical method, simple and easy to use. Materials of different sizes can be separated easily. Demerits. Presence of moisture in the powder is a region of aggregation and thus desired particle size is not obtained. Now, air separator. Principle. It works with the principle of centrifugal force. Construction. It consists of vertical metal cylinder vessel with conical base at the bottom and the feed inlet at upper part. the central shaft of the rotating disc and blades to produce air environment. Two outlets for a fine and the heavy particles are present at the base of the vessel. This is the diagram. Construction hopper, rotating disc, rotating blade, outlet for heavy materials, outlet for fine powder. Walking. Firstly, the powder is fed through inlet. The motor driven disc and blade rotate and produce air current. The fine particles picked up back by the air and carry into the space and fall down that are collected at the outlet of the fine particles. The heavy metal fall down and collected at the respective outlet. Uses. It helps in the size reduction and size separation. Thanks for watching.